So welcome to a special seminar of the SONY Astani Department of Civil and Environmental Engineering. Today our speaker is Eduardo Fierro. But before I tell you about our speaker, I'd like to tell you why you are here and what's going to happen. As you know, a devastating earthquake happened in Haiti in January this year, January 12. The casualty count is very high. 250,000 people lost their life during this earthquake. But what maybe you don't know of, that the tragedy is still on. There is still 1 million people without housing, people without sanitations, without proper drinking water. So there is a human tragedy out there. So USC has decided to do something about it. There will be a high-level meeting next week. The ambassador of Haiti will come to USC, and many other high-level government people will meet. We are preparing a plan for them. Part of the plan is to address the issues of construction, how we can actually help these people to build safe housing so they can actually go back to their home instead of living on the streets. We also want to address the issues of drinking water, making sure they can drink safe water and also can dispose, can have sewers which are working so we don't create infectious disease which will obviously make things quite worse. So we are planning here. We're going to have to plan thinking about it's not a developed country like our countries, but a country which is somewhat underdevelopment. So Eduardo now comes. I call Eduardo. I met Eduardo. I've heard of Eduardo before, but I met him in Japan. He gave a brilliant talk, and I said, I want Eduardo to talk at USC and tell you what happened in Haiti. So Eduardo was born in Peru, Lima, received his Bachelor of Science from Catholic University in Peru, then moved to a university which is a challenger to USC on the football field. Notre Dame. No, I'm not talking about USC. I mean UCLA. You know, there are no challenger. But Notre Dame. He graduated with an MS from Notre Dame and then got his doctorate, his PhD, at UC Berkeley in 1991, working for the advisor. His former advisor was a famous man in the field of structural engineering, Professor Botero. After his graduation, he became an engineer, and he worked for several firms, including John A. Bloom Associates in San Francisco, Dames and Moore in San Francisco, with Gianni Itznes, and also I believe in San Francisco, and now he's working with BFP. BFP standing for Botero, his former advisor, himself, Fierro, F stands for Fierro, that's the middle initial, and Perry. So we are very fortunate to have Eduardo to help us to plan the recovery of Haiti. Eduardo, the floor is yours.
Good afternoon. The first thing I'm going to ask you is please put your cell phones on silence, if you could, because that disturbs me very much, and I stop for about an hour after a phone ring, okay? So, I have to thank JP for inviting me here. I think it's very important that people hear firsthand what an earthquake of this level, and I'm not talking about magnitude or intensity, I'm talking about level, and it should be understood very clearly that we are talking about level of destruction, level of no preparation, and level of human tragedy. This was really something that was very difficult for me. I am a person that goes to most of the earthquakes around the world, and I have seen devastation here, there. The last earthquake that I went was in Chile, where there were many buildings damaged, and it was a big earthquake, but nothing like this. So I want to try to give you an appreciation of what happened in Haiti in terms of destruction, in terms of what could have been done, why did this happen, and what is our responsibility as engineers. I mean, we are the ones that are putting these things together, or at some point we're going to be telling people how to do these things and directing the masons and the construction. And I would like everybody to take this thing very seriously, because when you become an engineer, and like we say in Peru, the engineer of the pickup truck, well, engineers have a pickup truck. They are completely divorced from the workers and from the work. They're just high-level people, not like here in the United States that engineers are medium-level people, you know. So take it at heart, and sometimes I get a little bit emotional. I start sweating. If I start sweating, I'm going to take my tie off. I normally don't wear a tie, but I thought it was appropriate for an institution like this. Doesn't want to come down. Okay. Human toll, you guys can read. 250,000 people. Some people are saying now that it was not 250,000, there was about 100,000. But there's no way that they can count there, because many of these people do not have IDs. And I will show you later how the bodies were disposed of. So 350,000 people injured, you know, 134 rescued by international teams. You know, the amount of money that was put into this rescue was very little compared to what was accomplished in terms of rescuing human lives. But of course, you have to think, if this was my mother or my son or my daughter, every one of these ones counts, you know, very well. Yeah. So 9 million people, population of Haiti, 3 million affected by the earthquake, displaced people about 1 million, and JP was talking about this. These people are living in the street now. They are living in the street on tents or on sticks with blue tarps, or sometimes not even blue tarps, but garbage bags that make the walls of this. And the rainy season is now just started, so they're suffering very much with respect to this, you know. People left Port-au-Prince and they're living with their families somewhere else. 50 aftershocks at the time I wrote this thing, not many more, you know, maybe 70 now. These are the percentages of effects on children. Foreigners, you know, there were 53 missing, dead, you know, and there were 4,800 Americans unaccounted for. I think that this number has come down, but there were many that were dead. Now, the question is, we talk about a natural disaster. You know, is this a natural disaster? You know, or is this a man-made disaster? You know, whose responsibility is the society of Haiti? Is the government's fault? Whose fault is this? You know, why did this thing happen? You know, did these people have to die? And I'm starting this thing emotionally because I want you to get into the mood of this. You know, bad design kills. So if you design it wrong, you're killing people. If somebody's building things wrong, you're killing people. And this is not a joke. You know, you might think that this is a joke, but it's not a joke. Okay? Any of these things happen, you know, people are going to die. And you have to see the people dead in the street to appreciate these things. So this is very important. Ignorance. Not to know what to do, how to build, how to do things, how to run, how to escape. and then the collective ignorance also kills. Now, let's say that we were in 2008, and you are in charge. You are in charge of Haiti in 2008. Was any way that you could prevent this thing? Was it possible for you to prevent this thing? What about if it was 1998? Was something possible? Could have you done something to save these people? Let's go back 20 years before. And you guys have to answer that question after you see this presentation. I'm going to tell you what happened with housing, what happened with the government buildings, what happened with the infrastructure, all this stuff. The earthquake is a small earthquake, 7.0 for South American standards. We have had like 6 aftershocks of that level after the Chilean earthquake. In South America, those earthquakes are, we call them tremors. They're not big earthquakes, but and it happened somewhere here. Port-au-Prince is here. Happened very close by, and the rupture was in this direction. Very important, because you will see that the part of Port-au-Prince that is from here there had very little damage, so there was a lot of directivity because of the direction of the rupture. Tectonic faults of the Española, the Enriquillo plantain garden is the one that produced this thing, and it stops here. Maybe not. Then there is another one which is right here on the north of Haiti, and another one there, and this is the one that is going to destroy Dominican Republic, on the center of Dominican Republic. Cylindrical earthquakes. You can see that the last big one was, in 1770. That was a long time ago, 240 years ago. So the collective memory of these people with respect to earthquakes did not exist. This is, 240 divided by 20 is 12 generations. 12 generations, you forget everything. You even forget math. Just look at some of the countries that the world that invented math, and they don't have it anymore. So, so that happened there, and there have been major earthquakes here. But since they're so far apart in time, nobody pays attention to the earthquake now. Now they're going to pay attention, and this is the opportunity that we have to seize to produce something that is worthwhile in terms of earthquake design. The epicenter is here, rupture is in this direction, and all these towns were more affected than this area. Now, Logan was 90% destroyed, and this town also was very, very destroyed. The estimates from USGS are that the PGA was about 30% G, which, in my opinion, based on what I saw, I think it's very small. I think that it's a little bit higher than that. This is a period of 0.3 seconds. That's 0.6 G. So for the peak of the spectra, you're having 0.6 G. And this is the comparison. We're going to go fast through this. And this is the intensity map for the main shock and for a shock that was a 6.0. I was there, and I didn't feel it because I was driving at 6 o'clock in the morning, and I couldn't feel it. So that's why I always use my computer. There we go. So this is the Dominican code, and the earthquake in Haiti is the red one. So the Dominicans are very happy with this thing now, because they say, well, yeah, our code complies with that. The only problem is that USGS just published, some data that puts this thing at twice. So the earthquake that they can expect there, it's about twice. So Landslides. Now we're going to go through, see the landslides. This is what happened you're driving through there, and then you see these landslides. Landslides. This car was parked up there, and this is just a pictorial way of seeing. If you put a slope next to a road without any protection, that's going to happen. Okay, so any place you go and say, oh yeah, this is okay. No, it's not okay. This is what's going to happen. A masonry wall as a retaining wall. Now, your secondary effects is that these posts were up there. This light post, electricity. This is the road that goes to Pétionville, which is the rich part of, this is the Beverly Hills of Haiti. And that's what happens. You lose everything. That's PVC there, so it's all poison. That's some of the roads. You can see just lateral spreading. This is not the fault or anything. It's just lateral spreading. It was not well compacted, and that's the landslides that close the road. Now, I'm going to ask you here, was there an earthquake here? Does it look like there was an earthquake there? No. Nothing happened there, The same earthquake happened here as on the other places. But you see, this is when we do not intervene and put things that are going to fall. Okay? We're not intervening. This is debris from building that fell down. And this is what happened. This is what happened. Look at it, some reinforcement, very little, complete destruction, unreinforced masonry. This was caused by whom? By the earthquake? Or by the construction people, or by the engineer? Okay. Or by the government? So you start getting your answers now about this. Who did this thing? Not the earthquake. The earthquake happened, and if we don't put our hand and build wrong things, this doesn't happen. So now I'm going to give you my initial impression. I land in Santiago, Dominican Republic on the 13th at 3 o'clock. Next morning, there's a jet waiting for me to take me to Port-au-Prince. We fly for 20 minutes, and then we fly for 2 hours, then land. No papers, nothing, just walk in. Walk into the country. Are you here to help? Okay, come in. To get out, are you here? My plane is leaving, so please let me out. Okay, so go. That's the level of, we were talking about government before with the JP, and say, where's the government? There was no government, okay? So, initial impression from the air, you start, this is Google, and this is what you see. You don't see anything, well, something happened there, and then you look at this and say, well, maybe something, remember the tank farm, okay? Please remember it, okay? And then you see, well, what happened with that crane, There's something happened, there's a crane in the water. Why do they have cranes in the water? And then, a crane in the water, another crane in the water. And then you start seeing these things from the air, Wow, something happened here, a frame building with all the joints. All these are the joints that were unreinforced, and joints that are unreinforced will break right there. And then you start seeing the total destruction. But it's not total, because nothing happened to this one, and some of them are okay. And you see this building, This is the this is the telecommunications building. So imagine what communications we had that day. It's not possible, only satellite phones. And this building looks okay. It's completely damaged. So you start looking at these things and you go, and this is an area that I actually studied very much because somebody had done an evaluation from the air, from the satellite photos, and they wanted me to verify that evaluation, and they were about 30% wrong on the evaluation from the photos and the evaluations from the ground. So, and that's the government buildings, all downtown. That's the Palace of Government. This is where the president was, and That's it. That's what happened. We'll see some more of that. Completely destroyed, completely useless, with all the files of the government. Everything is inside. They had to go. Some brave person had to go inside and look at these things, and you can see again. So this is from the air. Just the cathedral destroyed. That's the cathedral. More destruction. More, and this is some of the slopes in which this is what they call some of the slums. That is self-construction. And you can see that most of these things. What's that dark line? Is that like a ravine or a valley? Right here? Yeah. It's like a creek. Yeah, like a creek. Yeah. Yeah. So you see this. Yeah. And then you see this building. This is a new building. This is not a. This is an engineer building. Somebody like you, I hope maybe not like you, but somebody that had an education as an engineer from Berkeley. It's probably from Berkeley. No, from Notre Dame, from the University of Notre Dame. Did this thing. And look at what happened. You can see here that there is damage at the joints. So. This is the hotel where any of us would have stayed if we were in Port-au-Prince. This is the Montana Hotel, and most of the foreigners that were there died. This is a $150 a night hotel. So that's what I would have stayed if I was there. You would have stayed there, and we would have be completely dead. That's the Montana Hotel. Now from the ground. I started driving. We get to the airport and I start driving, and you start seeing the walls. The fences that fell, and then all of a sudden, this is not. I'm not choosing a house. The guy's driving, and I'm taking pictures continuously, and this is what happened. See. And I'm not stopping to investigate these things because I need to know what's happening first. This is a slab. This is not a slope. This is a slab. The building is down there, and it lost one floor, and you can see. And this is new construction. So you can see here. We'll see this one later on. This is the reinforcement. Not enough stirrups. And older buildings, and this is what I'm seeing while I'm going in a taxi. This guy wanted to charge me $400 for a 20-minute ride. I said, no, I'll give you 10. He said, no, 50. So 50. So, and that's. Now let's look at the concrete details. Is this what killed the people? This is a column. That had a wall here. There was a wall here, and this is a column that has 4 little bars, and the stirrups are 1/4 of an inch. Some of these bars are number 3 bars, and some of them are number 4 bars. And look at the quality. Now you see this open. This is open stirrups. Open stirrups. They had them in Chile also. So. Don't think that it's only here. They had the open hoops in Chile, and that's how big. That's my finger. Okay, so that's how big the bars are. Very small, very little reinforcing, and that's the spacing of the bars. Very little, and that's the typical construction. You have a wall, a block wall that you build first, and you leave the reinforcement, and then put 2 formworks on the side, and then fill it with concrete, with bad quality concrete and not very well consolidated, as you're going to see later on. See, that's the consolidation of the concrete. So those are the details of a building in downtown that collapsed. First, this is smooth bars. Smooth bars, no joint confinement, and this is secondary failure. Don't think that this is the main failure. The main failure was on the first floor. But this is how the joints were everywhere. So that's what happened. Smooth bars with very little reinforcement. The same thing here. You can see, very little reinforcement, all smooth bars, and the lap joints were not long enough. Now, I was telling some of the people in Haiti, well, when I gave a talk about these things there, I said, look, you have smooth bars, and they're going like, oh yeah, but that's all we had, and you have to remember that we are a third world, and we don't have them. So I showed them this picture. So what about these ones? Huh? Well, those are the beam bars. They have to be anchored. I said, oh, these ones have to be anchored, but these ones don't. That's the level of knowledge that they had, So, and this is the construction, it's a detail. That's a column with all the open hoops. Yeah? And you can see here that there's, in this one, maybe there's a hoop here, but there's no hoops. And they're all rusted. Rusted because the sand that they use was beach sand. Yeah? They use beach sand. They have the beach there. You use beach sand with salt, and 10 years later, that's what you get. Detail. Second trip, I was there. I'm good for punishment, so I was there again for a few days on my second trip, and I'm entering the. This is like 15 kilometers away from Port-au-Prince. I'm entering from Haiti, from Dominican Republic, and I see this. Oh, I'm going to stop because I want to see what kind of details these people are doing before. This is far away on the east side, so it didn't suffer, the damage. So I'm gonna let me look at this, and then I start looking at this, and I see this little column, and then you see the beam, you can see the reinforcing here, and you can see it better over there. It's just unbelievable. And the consolidation of the concrete is very poor. You can see the bars. So they have no support between the formwork and their bar. They just put the bar on top of the formwork and pour the concrete. Don't do that. And then, this is my Chilean friend that I told him, Antonio, you have to come with me to Haiti so that you can see this thing. Then after that, this is before the Chilean earthquake. Then we went with him to Chile. He showed me Chile afterwards. And that's the thing. And I was puzzled by this. You see here, 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 here. Those are port joints. And what they have is they have a bucket, 5-gallon bucket that they go and they put on top, and then they go and mix. So it's a little dry, when they finish mixing the second part, and then do it. It took me a long time because there were some parts that were so flat that I thought, do they put some things there and then they fill it with concrete? But no, so port joints, And that's the reinforcement, very little reinforcement on the columns, a lot of reinforcement on the beams because gravity always acts. So if they don't put reinforcement on the beams, the thing will fall down immediately, And that's the detail, of the. Now, this is a wall and a column.
Why is there an offset in the wall?
Yeah. Come on. Ooh, slow. Your machine is slow. Sorry. Can we? Yeah. What happens is that we need to.
It's stored in the computer itself.
It's in the computer.
Yeah.
This is in the computer.
Yeah.
No. Let's see.
It's in the computer.
Okay, go. Let's open it from the computer then. Please. Go to the. There. Do that one, please.
This one?
Yeah. Okay. That's what. This is what they had there. There's mortar there, and that's what they had. So that's the little one, and that's. See, You see how this thing moves? Up there? That's the detail of the wall with this. So, yeah, what's going to happen? I got it. Yeah. So now we go to don't tell me it's going to go to the next. Okay. So now we're at this is the first trip downtown to Port-au-Prince. What time is it, please? So I need to accelerate this. Okay. So still have time for 300 slides. So. Correct? So that's how it looked. This is Google before. That's Google after. Fortunately, Google saved their images, and that's before. That's after. And that's the government palace. Very heavy masonry building with some reinforcement, finished by the U.S. Corps of Engineers in 1906. And you can see here that there was very little reinforcement on those columns and very little attachment. That's the level of reinforcement on that column that had failed. So there's not a mystery here of why this thing failed. We know it was poor construction and poor design, poor construction. So we don't have to do a master or a doctoral thesis for this. We know what happens. However, and you can see, there's a column here with you have masonry on both sides, column there with masonry on both sides. If one of the rules of earthquake engineering that Professor Bortero taught me and taught some of the ones that are in this audience is the structure has to be light. Your structure has to be light. This was not light. This was a heavy piece of building, with not enough reinforcement. And you can see here, all these bars are rusted. And you can see that these bars end here. They end here because they have been corroded completely. So there was some reinforcing here, and it broke where the reinforcement was non-existent. So now we've solved that problem. We know why it fell, why it. And you see the bars that are, look at the bars. They become thin to a needle. The point of a needle. So you can see more of these things, and the rubble inside.
Also poor quality concrete.
Poor quality concrete, absolutely. This is. I was told that the U.S. Corps of Engineers finished this thing. That's what the government of Haiti is saying. We had this thing, we started it, and then they finish it. So I have a hard time believing that in 1906 we were building this bad, even in a foreign country. But that's the story. This is walking around downtown, and you could see that, you end and you have your corbel, you have this thing, and then where is it going to fail? Where is it going to fail? In the part that is stronger or the part that is weaker? The part that is weaker. Oh, right, we know. Well, it failed there. Okay? So, you've seen that detail. And this is what you encounter walking the streets of Port-au-Prince. This is just unbelievable destruction. I've been to many earthquakes. I go to all of them. I've never seen this thing. This or the human tragedy that you will see later on. And but the level of engineering in Haiti, in my opinion, It's very poor, but you see this thing? This was here. You can see it better there. It was here. Somebody in their mind said, I need another floor, and I don't have a column underneath. So I'm going to put this big cone to spread the load, and then put a column there. They were about to put another floor here, you know? That's the level of construction that they have there. I mean, I don't know if there was an engineer. I'm sure that, you know, maybe there was an engineer, because how would the builder, the guy that is is going to build this thing, going to think that they have to spread the load? Yeah, maybe there was an engineer there, but yeah, that's the level, okay? That's the level of stuff. Now, I went to this building a month later, and it was exactly the same. A month later, it has not moved. I'm going to go in about 3 weeks. I'm going to go again, you know, and see if it's still there. But the demolition, and you'll see the demolition was being done by two people. A 5-story building. There were two people with a chisel and a sledgehammer, and that's what they were to recover the steel, because this is valuable. Okay, this is so that we can see. We're going to try to solve this problem. JP has just told you, hey, look, we got to solve this problem. We got to help them. We got to know, so that you get into the mind of these people and think, what is happening? How can we help them with their mind? Because we cannot just go there and say, okay, we are Americans, and we're going to do these things, and we're going to solve the problem. No, it has to be integrated with their way of thinking. You know? There's one story here that is non-existent, and this is a 6-inch column, 6 inch like this, you know, for a 4-story building on the first floor also. You know? So you can see that there's no steel in the joints, you know, and the column breaks in the middle, and that's the connection. You know, this is the type of connection that you have. Another building, the same thing. You see the joints, and this is the communication building. You know, you can see the blue thing here that we saw from the air, you know, and it's there. You can see that there was no communication in Haiti, you know, and that's a building that was very badly damaged, and that's the cathedral. Cathedral after. No. See, and why did this fall? These are not hoops, but these are flat bars that are put in there so that the steel is held together. You know? So when they build this thing, they said, we need something to put it together so that when we pour the concrete, you know, they stay in place. So this was it. So no shear reinforcement. You know, now, was this a big earthquake? Yeah, it was a big earthquake, but this is a building that could be in Chile. You know, this could be a Chilean building. You know, big wall, another big wall here, another big wall here, elevator core. Nothing happened to it. I went there and I looked at these walls. What happened was that some of the glass broke, and the building was completely undamaged. Yeah. So somebody knew what they were doing there, or maybe they were lucky and they put enough shear walls. But that's the American embassy, which nothing happened to it. Of course, it was in the part of away from the propagation of the wave. Nothing happened to it. Unfortunately, when I was in Miami, somebody said, yeah, it worked fine, no problem, but you know, it's in the floodplain. In 1954, there was 3 meters of water rushing through there. So somebody did not make a...
When was the embassy built? Do you know?
When?
Yeah.
Like 4 years ago.
Oh, recently.
Yeah, recently, yeah. So this is a new building. It had no damage at all, you know. But according to the Haitians, it was built in the wrong place because they're going to get water there. Yeah. Corner buildings, if you have ever been to a earthquake, corner buildings are always destroyed because the building that is in the middle pushes on that one, and then this one pushes on the other. So you go to an earthquake zone, and all the corner buildings are gone. and these ones were not. And they were not because there was no big building on the other side, and there was no big building on the other side, and it was cracked, and it had one wall here and one wall here. The rest is all open. It's an
It looked like a soft story design.
yes, but this was enough. This was enough, and there was directivity also in the wave. There were I was able to see that there was one direction of dam, and not only in only one direction, but in one direction. You could see that in many places there were no exits, but there was just one diagonal crack. So this is downtown Logan, and this was 90% destroyed, and you can see there, look at this thing. This is Masonry Buildings, the yellow clay, because they have yellow clay there, and you walk in and you see this and that, and it's a wood building on the floor, and then one that now. One of the things that is very important here is that many people are saying, my building is okay, so it's okay for earthquakes. And I have been telling them, look, these are very fragile buildings. And the equivalence is like, if I put a piece of glass between here and there, a plate of glass, and I get one of these young ladies that is very light, and they walk from one place to another, nothing happens, they go out. And then I go and I get into the glass, and the glass collapses. These are very brittle buildings. So having them not damaged doesn't mean that they're good buildings. It means that they're strong enough for the earthquake that came. But if a stronger earthquake comes, they might be in the same shape as these ones. So the church, this is the church with a very light roof. You can see the connections here. They had no hoops at the plastic hinges, so that's what happens. Now, this is the municipality of Logan, so you see this thing here.
That's classic.
Yeah, that's just your classic joint that goes through the column. This thing goes through the column, and that's the masonry building. Sorry. Now, you can see that there was movement here, because you can see that the fence is all gone. So there was some movement. But of course, you saw how they were built. So you could move them with your hand, and if you push them very hard, you will be able to take them down. But nothing else happened here. There was no damage here, because principle of earthquake engineering, light structures, light roof. That's a light roof. So
What do they use for roofing material? Just concrete?
most of since they have hurricanes, most of the building have a slab that is between 5 and 6 and 7 inches, depending on the span. A concrete slab.
So how are they waterproof it? No waterproof?
No waterproof, just
Just a bare concrete
just
slab?
bare concrete. Yeah. So, so this is a school. This is a nursing school. This is an example of, again, we have a parking lot here. This is a parking structure. A canopy for parking. Why do we need this heavy slab on top? Somebody tell me, why do we need if the hurricane comes and takes the corrugated metal, so what? It took it. We put another one, but no. And that's the detail. No hoops, smooth bars. Bad quality concrete. Now this is the canopy. Now this is the school itself, and you see there's 300 nurses that died here. 300 nurses died here, and you can see, wow, what happened here? But fortunately, in many of these structures, not everything falls. Only some parts fall, and you can see it. And this is a great example of what happened here. So you see here, and you say, well, I know that this part failed, but I don't know why. And then you see there, yes, it failed, but I don't know why. Then you start looking more and said, well, let me go. This part is not. Now you see this one. There is where you're going to find out what happened. So you see it, and then you see, look at this. This thing was up here. This was up here. You can see, whoop, this was up here. This thing move like this, the joint, you can see that this joint failed, and then it slid down there. Now, that's good clue. But what else happened? You know, when you investigate damage, you say, why did that happen? You know, and then you go and look at this, and then across this thing in the same area, you see this undamaged building. Oh God, I wish it had some little damage, you know, to see what happened. And you go to the corner and you see the little damage. Ah, look, and then you see here. This is what happened. This strut is pushing this thing, and you can see that it's deformed. Yeah. And you can see that the concrete went away. It had some hoops, not enough. But the worst part is that this is what, the first time I saw this thing was in Turkey. It was the earthquake-made short column. Okay? You've heard about the short columns, you know? Short columns, they try to deform in shear, and in this much of concrete, you cannot have enough deformation to absorb the spectral displacement that this earthquake come at whatever period, 0.2, 0.3 seconds, you cannot have enough capacity of deformation. So these things fail. But this was made by the earthquake, and we saw that it's like the same thing that we saw in Turkey. The earthquake made soft story. You have a building with walls everywhere, but the shear is bigger on the first floor. So first floor gets damaged, walls fall out of plane, and now you have a soft story. And you get collapse. So you gotta go faster. Main port, that's the main port is located there. And you see these lines, whoop. That's where the port was, and that's what the port disappeared. It was there and disappeared. There. And those are the pictures of the port. There was damage because there was fill. All these parts here that you see white is liquefaction. You'll see that's the side of the port where it was not compacted. It was just rubble that they put in there. Then they put the asphalt, and all this white stuff is liquefaction. So you get lateral spreading, destruction of the fill, and then liquefaction at the same time. All the white stuff is liquefaction. Liquefaction there. The port was here. That's the crane there. Now, you see all this white thing? You see the level of water was here. After the moment of the earthquake, start shaking, the water comes up, earthquake stops, and water comes down again and disappears. So, but this is the mark of how much water it was ejected there. This is for the people that are specialists in soils and liquefaction. You can have this much of water. And liquefaction, This is the port that didn't get destroyed. I did some inspection of this thing for the Army Corps of Engineers because they were saying, can we use this thing? And then I went there and said, let me look at it. So I told them, yes, do it. In the afternoon they were using it, and they're still using it here. The fuel port, there's a fuel port here. There's the fuels, the tanks with fuel are here, and this was the port. And was the port, and that's what the whole part collapsed. This is the collapse, and you can see the guy was lucky there. Half a truck was inside. Lucky guy. And then you say, well, what happened here? And then you start looking, and there was some subduction here, and this is already filled because between the port and the land. It was completely, there was a hole there, so people were wanting to use this thing. So I see this thing there, and they wanted to use this one. This one they wanted to use. They said, oh, maybe we can use that one also. I said, let's look what happened. I said, I don't think so. And then I went and took picture one by one of the piers. And you can see here that it's already gone. Another one that is already out.
What kind of piers do they use?
There are steel piers. There are steel piers here with a cap not attached to the yeah, not just attached. Yeah, no, not attached. You know, so you can see them there. You can see that they're not attached. You know, it's just gravity. You know, they build this thing and then they put the deck on top. You know, and there, all of them.
It's an active earthquake zone, isn't it?
Yeah, yeah. Wow, 240 years. There has not been an earthquake here. I mean, you were late, but yeah, there were. That's all right. I'm going to repeat it for you. There hasn't been an earthquake here for 240 years, you know. So they forgot. You know? And there you go. And this is something that I never believe in. So everybody is telling me, oh, punch and shear, you have to design for punch and shear. They said, forget about punch and shear. This is punch and shear. The piles, and up there, that's punch and shear on the slab of the pier. Yeah. Airport, not much happened at the airport, you know. The tower is always damaged. Tower is always damaged. I don't know why we do these things. You know, you put 4 aluminum mullions and we think that this is going to hold, you know. So, and that's the damage to the airport. Not much, you know. Mostly non-structural. Electrical power plants, you know, there's one next to the other one. One given by the government of Venezuela, which behaved better than the old one. And that's the old one we're talking about. And transformers, they fall. You know, 6 transformers, 1 of them fell. Yeah, so if it was a little harder, all of them would have fallen. But they're always in wheels, because every 3 years they have to repair them. But put a bolt and and that's the support that they had. So if you put something like that in an earthquake zone, it's going to fall. So don't do it, please. Now you have seen it. You know, that's why I go to earthquakes, so that I don't make the mistakes that other people have done it. And that's why I come here to tell you, so that you know that you shouldn't do these things. You know, that's the... Now, motor control centers, see? Not anchored. Oh, they're very heavy and I cannot move them. Of course you cannot move them. But the force is proportional to the mass, you know? You don't have enough force to move them and they seem anchored, but they're not, you know? So you have to anchor them. Yeah? This is the duct, the exhaust from the generators. You know, it comes out, and they were the opening was not designed properly with enough clearance so that the building can move and the thing not get damaged. And you see it. All of the exhaust pipes got damaged at that time. Now this is the other power plant. This is the Alba power plant. Mr. Chavez from Venezuela gave these people this plant. And you look at this thing, and these ones are normally damaged, and they were not, meaning the earthquake was strong, but not that strong, because these things take about 0.35, 0.4 G, you know. That's what they take without damage, you know. So, and then you see this, and then I look at these transformers, and I say, well, nothing happened to this, you know. And then I observe closely, and you can see here that these bolts were pulled. All of them were pulled. No major damage, but you know, they were pulled. All of them, the 6 transformers that they had, they were pulled, you know. And this is a structure, you know, steel structure. Nothing happened to it. You know, not 100% good design, but 90% good design, you know. There's oil from the, these are the generators, you know? Yeah, they were, and this is firewater. At least one tank that has 80 cubic meters and the other one that has 100 cubic meters. So 20% different in weight. This one collapsed. This was sitting on, this is a block that was sitting up there. I'm going to show it to you. Yeah. It was like this. It was like this one, you know. But why did it collapse? First, it didn't have any steel, very little steel. It had some steel, but very little. You can see it here, you know. It pulled, you know. This is your tension failure. The one in the experiments, you know. And maybe if you were lucky, you've seen them. You know. But this didn't fall because this thing fell first. If it fell because in one side you got welded, you know, they didn't do it right, so they put one weld, and then you're shimming this thing to death, and then the same thing on the other side, you put the shims, and since this is, it's hot, you have to let them move. So on the other side, you don't put anything, you know. So the other side has no support, not horizontal support in any direction, you know. So that's what happened. So what I think happened here was that the well broke, this thing went like this, and at the point where it was falling, it hit the wall with speed and then broke the blocks. So, sorry. If you don't attach your tanks and put pipes next to it, they will fall. They will break. Okay? Nothing happened to this, but it's unusable. And all these diesel tanks, you know, since I think diesel is a little lighter than water, it's like 70% or something like that, or yeah, it's a little lighter. It's like oil, you know. So 100 cubic meters, they did not fall. Water tank. This water tank is a water tank that was not damaged at all. Zero damage, you know. And you can see that there was only damage in the foundation, or not in the foundation, but around the foundation. There was nothing that happened there. And you can see that there's this big wall, four big walls with a column in there. And, you know, that's the way that you build, so that even if you build it wrong, even if the details are wrong, the concrete is bad, if you put enough beef there, you know, it doesn't fall. So, and, you know, one of the things is that I gotta tell you this story. When I'm here, you know, these guys, one of them spoke English. You know, I said, "You have a job for me?" "No, I don't." And you see my size, I'm not scared by many people, you know, don't. So they start going like this. "You have a job? Give me some money. Would you hire me?" I said, "No. And at that point I realized there's 9 guys here, 20-something years old. They're going to pull me apart. So I start talking to them, and I told them, "I need a favor from all of you. Can I have a picture with you?" So this is the picture that my Dominican friend took, and now we're all friends. But very important, if you ever go to Reconnaissance, make sure that you're in a place where you cannot be harmed. I mean, here, this was a mistake that I made. You know, I was able to correct it, but it could have been a disaster. You know, I had a camera, I had all the equipment, the video camera, and money in my pocket, because you have to deal with cash here in this. So I could have been, you know, fuel tank farm. This is a fuel tank. For all American standards, this thing should be closed, and I will tell you why. You know, that's the way the tanks are. You know, they're all damaged on the top and all wrinkled. You know, and this is something that I had never seen. This one is the elephant foot. Everybody has seen this, right? This one here, first time in my life. I said, "What happened here?" It changes section. You can see that the well here is smaller than the well here. You can know the size of the well because this is full pen well, and you can see that one is like this and the other one is smaller. So the section, the thickness changes. So you get your buckling on both sides. Pretty cool. You know, somebody's got to do some thesis about this. Masters would be good. And that's you know, steel factory. We'll go fast through this. This is a steel factory. It's called because they straighten steel, and those are the, you know, the buttresses that were supposed to hold. And if you can see, you start looking, and there's no rebar that goes through there, and that's it. You know, there's no rebar. The guy put the thing there, put the column, and didn't put the rebar through the stuff. And the same thing there. You know, there's no rebar. They put the column in there with the 4 bars, and that's it. So, level of construction, the cement factory. This was, and the guy was telling me that this was a award-winning pier, in which what they do is they put sheet pilings around, and then they fill inside with rubble. Yeah, they do this 1, 2, 3, 4, and one of them open. You can see it over there. One of them open, you know, and it was damaged. You can see it over there, you know. This doesn't change. So, low. So in here, we have the conveyor belts that fail. And the guy that is telling me says, oh, that was not a failure because we're not using them. So since he was not using them ever, that was not a failure for their factory. But they had a lot of failures. The same thing up there. You can see up there that there was a failure there. They didn't put all the bolts. They put the bolts every other one. And you can see, here, the thing pull out. You can see this thing, the whole thing pulling out. So yes, it pulls out. Landslides, that was a failure because that conveyor they were using. So we're going to go faster, and you see that tilted beam, there, and the collapse structures on top. Bridges. This bridge was damaged. It was not closed. Fortunately, it was not closed because there was no reason to close it. The only thing that had happened is that support had failed. Hold it, but you can see there that there's not a continuity. This thing was just put in there, and let's put some steel, and of course, there's reconstruction. There we go. That's a reconstruction. This is corrugated. And that's the way they're rebuilding, exactly the same thing. So that's why we got to do something about it, because they're rebuilding exactly the same way that they had it, The block with the mortar that is not cold, that is not wet, and little columns, and you can see, same thing. Quality of construction very poor, heavy and reinforced concrete walls. So that's the people that I went to that helped me very much. That's Palito. Palito was the chief of security of one of the engineering camps that had us there, and he never smiles. He has a gun, he has a gun in here, and he never smiles. So I made him smile. I made him smile. Now, for the end, allow me 5 more minutes. We're late, but this is what happened when you do the things wrong. Have it in your hand, in your head, If I do something wrong and if I don't check it right, people are going to die. Okay? And that's the way the people were in the street. Okay? In the car. This is 4 days later. Okay? And somebody tried to take these people from the rebel and had to cut their legs, and they died. What happened with the people, in the collapsed buildings, After the building collapsed, they pick up the rubble with people and everything. So you're going in the road, and that's what happened. The road, they dumped the trucks with people. Okay? That was common. What happened to the wounded? This is 4 days after the earthquake. This is the conditions that they had for medical care, and that's how they were living. This is living quarters even now. Okay, that's the way that people are living with rain and everything. So, if you have any questions.
Before we take questions, I'd like to acknowledge the presence of a few particular organizations in the room. I'd like to acknowledge the presence of Yvette Floret, who is coming from the Global Health Institute, from the Keck School of Medicine. Thank you, Yvette, for being here. I'd like to acknowledge the presence also of Engineers Without Border, and I believe Alex is the president. And I also acknowledge the presence of our ERI student chapters, the Earthquake Engineering Research Institute. So thank you for that. He's also the president. Did I miss any other organizations here? Hopefully not. But thank you for being here. So now we're going to take some questions from the audience. I'm sure you have many questions. We do have, however, to keep a schedule. We have a conference call coming, already late, but Eduardo still can entertain a few questions now. So go ahead.
And remember, please, there's no dumb questions, okay? If you have a question, it's because I didn't do my job right.
Something a couple days ago when Fabian was talking about Chile earthquake. I mean, there's a lot of regulation in that country regarding inspection and doing the, the paint. I mean, they're drawing and engineering, but it looks like there's nothing in Haiti.
Zero. There's zero.
Then
All these things are built.
the big plan that we have at USC and doing all this, mentality work on people. I mean, should we work first on regulation and making regulation and then go after, because
We were having a discussion at lunchtime about that. And I think that the assumption for whatever we do in Haiti now shall be that there will be no regulation. So the thinking has to be, how are we going to improve construction practices? How are we going to improve design? How are we going to improve the built environment without government regulations? Because I can almost assure you that the level of enforcement and regulation that is going to happen here will be close to zero, even after this big thing, because of the resources. First, because the government was destroyed. I've been talking with the people. I went to Miami, and there was a big conference, and there were many people that came from Haiti, and they're saying, well, we're trying, but it's very difficult. We don't have the money, we don't have the resources, we don't have the people that are trained to go and do inspections, because you have to have people that do inspections, first that they make enough money so that they cannot be bribed. We have to acknowledge the reality. So somehow the motivation has to be pride, I think. You have to teach the mason, the construction, the guy that makes the block, and the guy, the engineer, and the owners to say, look, this is what I want, on their own. And that's going to be very difficult. We're discussing with, what's his name? Hank? Huh? Hank, and he's saying, where is the regulation? I said, assume that there's no regulation and solve the problem. And if there is some regulation, then it will be easier. So,
I want to ask you a question which is certainly of interest to our colleagues in the School of Medicine. What is the state of the hospital, all the facilities, basically to keep public health? I mean, are they operational now? I mean, are the doctors able to practice their craft, or they don't have facilities to basically to work with?
I was there, last time I was there, I actually went to several of the hospitals, and there was a lab hospital in that was donated by Taiwan that was untouched. It was reinforced block wall, and this is where they do the lab work. It was completely untouched. Nothing happened to it. There was another one that was being repaired by Doctors Without Borders, and it was being repaired, but it was being just patched. So they had some cracks, and they had anti-seismic paint that they use. This is what you put it in and then paint it, and this is what in Latin America we call them anti-seismic paint. So after it's painted, it looks like this, and everything is okay. And there were some buildings that were completely unoperational. The main hospital, there were several areas that were completely operational. Now the problem with the hospitals that I have seen everywhere is that as soon as there's an X crack, the director of the hospital evacuates everything. It happened in Chile, it happened in Peru, it happened in Colombia. As soon as there's an X crack that is this much, which means the masonry cracked, the structure is okay, but we're afraid. So we take everybody out, and the building remains operational for 1-2 years. So
how much do you estimate the actual capacity in our hospitals have been reduced? Out of the 12 hospitals, how many really are now functioning? Are we talking about 50%, 20%?
Probably 50%, yeah.
So half of the hospitals will be still out of commissions now, several months after the earthquake.
That's what I would say, I will check that. I will check that when I go at the end of the month.
It's a very important, yes. Go Yvette, please.
The other thing too, you showed the pictures of the nursing school that was destroyed. The medical school was also completely destroyed.
Yeah.
And I know some of our medical team was whole separate kind of cohort of people that have been affected by it, not being able to now complete their medical degree. So the capacity in the country is decreasing because of that as well. And so I think in the rebuilding efforts, looking into rebuilding those schools along with the hospitals is really probably very important.
Yeah, one of the first things that I talked with JP about Haiti is what do they need? The first thing that they need is education. And I was talking about engineering, but I'm sure that there are people that are probably in their fourth year, or there's one more year of engineering that they have to do to become engineers, and now they have no schools. So one of the things that can happen is that many of the universities they don't even have to be universities. The city colleges that do engineering in the United States can absorb these people, and they have to give them a complete scholarship to live here with the promise that they have to go back, because otherwise, it'll happen what happened to me. I came to America to study, and then the system absorbed me, and I was never back, and I can see several foreigners here that might happen to them, So.
Any more questions for Eduardo?
Do you see any use of precast concrete components?
No. No, I didn't see any. It's. I looked for it. I look for everything. I've done this thing and I didn't see any. No precast. Yeah.
I was thinking to the regulation aspect, and I know the difficulty of having regulation and being able to implement it when there's absolutely no government in place. But at the same time, it seems like it's such an important piece of the puzzle, the rebuilding puzzle, that I think our colleagues at the policy school at SPPD would be really key also to collaborate in kind of the USC efforts.
You're in charge. You're in charge. I name you being in charge of put the regulations to work there.
Well, no, I know, but I think it's a piece that's.
It's a piece that is very important. Hard to get. Okay.
It's actually, yes.
You have to see the mentality of a people. These people 3 days after the big earthquake, with everybody dying and dead, they were selling kebabs and hot dogs and candy and Coke, cold Coke. And I'm going like, there's a disconnect between this and that. They're very hard people. They didn't get sick. They did not get sick as they should have gotten sick, because they're very hardy people. They're really very tough people. Otherwise, with whatever they had there, 250,000 people dead in the street, they should have a big pandemic stuff, So, but it didn't happen. I was there, and I didn't get sick, and nobody got sick. I'm asking, are you guys getting sick? I said, no, we're tough. So.
All right. Well, I think we should conclude this seminar. It's time, but before we do that, I think we should thank again Eduardo. Thank you, everyone.
Thank you. Cut. He's a frustrated cameraman.
I'd like to see Fabian and Alex. You get to meet you.
Señor, here. I normally take